Hi, this is your Professor Sudha Kolathuparambal, Section 10.1, Confidence Interval for Difference Between Two Means. I am going to cover two objectives here, the distinguish between the independent and paired samples and how to construct a confidence interval for the difference between two population mean. A drug company has developed a new drug that is designed to reduce the blood pressure. The researchers wish to design a study to compare the effectiveness of new drug to that of the old drug. So one way which the study can be designed is two samples of individuals are chosen and one sample is given the old drug and another sample given the new drug. After several months, blood pressures of the members from both samples are measured and they compare the blood pressure in the first sample to the blood pressure in the second sample to determine which drug is most effective. In this design, the samples are independent. This means the observation in one sample do not influence the observation in the another. And another way in which the study can be designed is a single group of individuals is chosen. They are given the old drug for a month. So old drug for a month. Then their blood pressure is measured. Then they switch to the new drug for a month and their blood pressures are measured again. This produces two samples of measurements, first one from the old and second one from the new one. And they compare the blood pressure in the first sample to the blood pressure in the second sample to determine which drug is more effective. This design, the samples are paired. The previous one, the samples are independent. Now let's see how to construct a confidence interval for the difference between two population mean. We want to compare the effectiveness of the new drug designed to reduce the blood pressure to the effectiveness of the standard drug. Here in this example we have two population, a population of patients who have the new drug and the population of patients who take the standard drug or old drug. So let mu1 be the population mean reduction for the new drug and mu2 be the population mean reduction for the standard drug. We want to construct a confidence interval for the difference between two population means. The point estimate for the difference between the population mean is the difference between the sample means. That means mu1 minus mu2 is x1 bar minus x2 bar. The corresponding sample variance is given and the variance of the difference between the sample mean will be the sum of the variances. The standard error, we will use this formula, that is the square root of that. Because we don't know the values of sigma 1 square and sigma 2 square, so we can approximate them using the sample variance. So we will use s1 square and s2 square instead of sigma 1 square and sigma 2 square and use those. So these are the formulas we need to know in this section. The critical value for a confidence interval is based on the student t distribution. There are two ways to compute the number of degrees of freedom. Simple method is degrees of freedom, take that as a smaller of n1 minus 1, n2 minus 1. The margin of error is obtained by multiplying the critical value and the standard error. So this is the margin of error. Then add or subtract the margin of error from the point estimate to find the confidence interval. This method is known as the Welch method, and it requires the following three assumptions. So first assumption is we have a simple random samples from two populations. And second one, the samples are independent of one another. And third one is each sample size is large, that means greater than 30, or its population is approximately normal. This is an example of constructing a confidence interval for the difference between two means for independent samples. So first read the question. A drug company has developed a new drug that is designed to reduce the high blood pressure. To test the drug, a sample of 15 patients is recruited to take the drug. Their systolic blood pressure are reduced by an average of 28.3 with a standard deviation 12. In addition to another sample of 20 patients, take a standard drug. Okay, one is for the new drug, right? The second one is for the standard drug. Standard drug also we have the mean and the standard deviation. Assume that the blood pressure reductions are approximately normally distributed. That means the assumptions are met, right? Because we have two independent random sample and the population is normally distributed. Okay, so we need to find a 95% confidence interval for the difference between the population mean. So difference between the population mean reduction for the new drug and that of the standard drug. So at first I am going to write down all the given information in the table format, so it will be easier while calculating the point estimate and the standard error. And I am going to write down the formula at the top. So the difference between the means mu1 minus mu2, that is between so this is the point estimate and this is the margin of error. Same thing here, point estimate and margin of error. So here we are subtracting that, here we are adding. Then we can find the confidence interval, or we can construct the confidence interval for the difference of two means. So I'm going to write down the step-by-step procedure, compute the point estimate. If you want everything at once, like using this formula, you can do that too. While looking at the formula, we can see that we know x1, x2, s1, s2, those are here, and n1, n2, those are there. So only thing we don't know, that is the t alpha over 2. So first find that, that is the find the critical value. So as I mentioned before, the critical value will be the smaller of n1 minus 1 and n2 minus 1. So n1 is 15 minus 1, that is 14, and n2 minus 1, that is 20 minus 1, that is 19. That means smaller of 14 and 19, which is 14, right? So we look for the critical value in the table A3, the value corresponding to the 14 degrees of freedom with the confidence interval 95%, because it is given 95% confidence interval. So T alpha over 2 is 2.145. So I'm going to consider this as step 1. Okay. Now step 2, I need to find the point estimate and the margin of error. So first compute the point estimate. Now compute the margin of error. Now construct the confidence interval. So the 95% confidence interval is mu1 minus mu2. The difference of mean is between. Subtract this from the point estimate, like add or subtract, that will be the easier way to say, right? So 11.2 minus 7.925, or add this. So 3.3, this is 19.1. Now interpret the result. So we are 95% confident that the new drug provides a greater reduction in systolic blood pressure and the improvement due to the new drug is between 3.3 and 19.1 millimeter of mercury. This is the manometric unit of pressure, and we read this as millimeters of mercury. So now you should know the difference between the independent and paired sample and how to construct the confidence interval for the difference between two population means.